Let's analyze a pulley system. Actually, a couple of pulley systems. Just lifting a block with one pulley and then lifting the same block with the same acceleration and same distance, only this time using two pulleys. Okay, for our system with one pulley, we'll start by drawing a free body diagram. Then we'll use that to find the tension in the rope. And then we'll compare the length of the rope that was pulled with the distance that the block was raised. Here's our free body diagram. Notice we've made the tension larger than the gravitational force so that the acceleration is upward. Our net force equation is sum of forces in the y direction equals ma equals the tension minus mg. We solve this for the tension, and we find that the tension equals the mass of the block times the sum of g plus a. We'll let the distance that the block is being raised be delta y. That's the same as the amount of string pulled above the block. And also, since one pulley is just changing the direction of the tension force, that's the same amount of rope that you're pulling. So D equals delta y. Now let's do the same thing for a system where there are two pulleys, one hanging from the ceiling and another one actually attached to the block. We will consider that the pulley is massless, so it doesn't add any mass to the block. Here we've drawn a free body diagram. Now to keep the acceleration the same, we have kept the total length of the tension the same. But notice now that there are actually two tensions pulling up on the block, one for each side of the pulley where the string is pulling up on both sides. We do our net force equation for this system. Sum of forces in the y direction equals ma, keeping a the same as we had before. And now it equals 2t minus mg. When we solve for the tension, we find that the tension is half what we had before with one pulley. So t equals 1/2 m times the sum of g plus a. If we keep delta y the same as before, now we see that the string is actually pulled twice as far because the same delta y has to be pulled from string on both sides of the pulley. I have to pull twice as far to get the block to lift delta y. D equals 2 delta y. If we keep the other variables constant, that is acceleration and the distance raised, adding a second pulley halves the tension. That makes it easier to raise the block, but the length of the rope is doubled. We'll find that the work done by lifting the block is the same amount in both cases. Work is the dot product of force and displacement. Here, the tension is the force. In case A, the work is the force dotted with displacement, so it's just tension times d. In case B, the tension is halved, but the distance is doubled, so the work is T over 2 times 2d. We can mathematically see that the work in case A equals the work in case B. In summary, we can see that if we keep acceleration and the distance raised for the block, adding a second pulley makes it easier to raise the block. The tension is actually halved, but the length of the rope pulled is twice as much. That means that the same work is done in both cases.